it's designed to show off the basic premise of the system, which is that it's complex. So the system is high information, and any intelligent, or any, not intelligent, but any capable programming system must be high information, because otherwise there's a limit to its problem-solving capabilities. The way we know this is proofs or programs as proofs, and then we just apply proof theory, i.e. algorithmic information theory. And so the FRDCSA mission is to maximize problem-solving capabilities, to improve the human condition. As we know, software can solve quite a few problems, and especially free software, because its distribution is not restricted. So obviously longer programs are not necessarily better. Just by adding some characters to any program doesn't make it more complex. But it's ultimately necessary, as we mentioned. Since we know, or since I'm claiming that bigger programs are ultimately better, well, how do you create bigger systems? And you could sit down and write them yourselves, which is what we do, which is obviously necessary. But there's also a strategy where you collect what other people have written and put that together. And there's quite a bit of software that other people have written that's very useful, that if you utilize is one of those bogus words, right? So if you use the software, you can, especially when you combine it in, like pieces on a chessboard. Individual pieces, their movements are limited, but together you can affect a large strategy for achieving your objective. So, benefits to packaging. What I like to think is why force everyone to compile software and configure it. Why distribute that task to the end users rather than moving it upstream to the developers? So whereas you would have n times n, number of software packages times number of developers, configuration attempts. If you just package them, you only have n, which seems to me to be a good saving.
But times the number of packaging systems too, right?
Well, there are tools for translating between the packaging systems like Alien. So we're using Debian. I'm using Debian for starters because they have a lot of packaging tools, and at the time RPM didn't have anything like AMP back in 2002 when I started. And now it has Yum, I think, or something like that. And I've been meaning to look more into that, but and they have RPM Find, which is a good start. But we want to improve Alien to handle Gen 2 and ports and as many distributions as possible, while flushing it out so that it handles the mappings more precisely between the distributions. I'm sure Alien was just something Joey Hess wrote really quickly to get the desired functionality. But I doubt it's the final solution. Excuse me.
Somebody else did that this week. I can't remember who. It was very funny. Well.
So,
Alien's pretty good though, I think.
Yeah, it's a very useful tool, and it's definitely what we'll use for starters to multiply or take the cross product of the Debian archive over the other system. So, so I just think packaging is something. Debian has very high packaging standards. So because of this, you can't get a package for, say, OpenSite or NGU or these other systems that are very powerful. No package exists because no one is taking the time to package it to that level of quality. But if we relax the quality assurance restrictions for the Debian main archive, we can automatically generate packages that while not being as good, they get the functionality to be end user, and that's very important, especially when you consider about the the program size constraints on proof systems. So that's why it's especially important to get the software out there. So, well, I propose that we start packaging software as much as possible. We want to develop a queue of what are the most interesting systems that we should package, because obviously you don't want to package some random false off the net unless there's a reason. And I'll talk more about how the system models the demand for software that should be packaged. And that's something that should be really a shared priority queue or something like that, which acts as a guide. It's not definitive. Obviously, you package whatever you want when you want. So FRD stands for Formalized Research Database. That's actually a misnomer. Probably better would be Formalized Research Library. It started as a project to create the world's largest theorem prover with the largest library. So it was combining all the different theorem provers like Mizar and Nucrol and I forget Otter and all the and all the, however you pronounce that, all the different libraries that are out there for theorem proving. And so they have one other project like it, which is FDL from mainly Cornell, but they haven't, I don't know what their status is, but that's definitely something that I pay attention to. The CSA component is what we'll focus on in this talk, and that is, before I realized that programs and proof systems, okay, I've never quite ironed that out, whether they are the same. There are certain contexts in which programs are proof systems. For instance, the Curry-Howard isomorphism, but that's intuitionistic logic. So I've never, my study ended before I was able to cement all of the theoretical aspects of the project. I moved on to the practical aspects. So the CSA was designed to collect and conglomerate software that was not, while not being a theorem prover, aided in the theorem proving capabilities of the system. So, for instance, infrastructure, operating system infrastructure, programs, just any program. So the CSA is to collect and apply just random software that solves random problems. It doesn't have to be theorem prover related. But with the knowledge that the two are really the same charge, I combined them into the FRDCSA, which explains the ridiculous happening. So it is a large knowledge base of software that is maintained and expanded. We try to generate installers recently as proof of, not proof, but validation of the thesis of the system. Other people have begun to develop software that aids in, the basic idea is as we package software, we can apply the software we've just packaged to making better packages and to making more packages. So that, so you start with what expedites packaging first so that you get as many packages made, thereby increasing the complexity of the system. So I was recently happy to see that Fossology was released, which analyzes the license, and that had been on my to-do list for quite some time. And they solved that problem for the most part. We still need to refactor it to use an ontology instead of a simple hierarchy like they're using.